Welcome to Study Loop.
Hello everyone, today we're doing chapter 29, problem 8, and this problem asks us to draw the product of each of these reactions. So if you see in A, if we just kind of draw this out, we see that we have a halide at the end, carbon, and the carbon, and off that carbon is a carboxylic acid, and then we're adding large excess of ammonia. And what we know about ammonia, it acts as a good nucleophile, so you can go through an SN2 mechanism to kick off our good leaving group here, giving us now an amino acid, and particularly the amino acid in this case is glycine. Next, what can happen in B is, just like in problem 6 what we did before, after step 1, well, this is a strong base, so the ethoxide is going to deprotonate the alpha proton, making a carbanion, at which point the carbanion can do SN2 attack to kick off this leaving group, being right here. The leaving group is on this carbon, and acid hydrolysis to remove CO2 and ethanol, and what you would get from that is, well, after step 1 you obviously get the carbanion. After step 2 you get something that looks like this. This is nitrogen. And then after the acid hydrolysis, you lose this group and you lose this group for the production of ethanol and CO2 through hydrolysis. And what you're left with is now your amino acid. Being valine. In C, what we have is an aldehyde that we are now going to make an imine from, and then we're going to add a cyano group in which we're going to have acid hydrolysis. So if we work through it, we can see that in the first step, what we're going to do is we're essentially going to now, what we're reacting it with is this aldehyde. 1 carbon, 2, 3, 4, 5 carbons. And then we're going to have our ammonia. So if you see here, this is going to exist in an equilibrium with HCl and ammonia. So ammonia is going to be the nucleophile, go through a mechanism to form an imine, essentially. So an imine is going to be formed. So we're going to have an imine being formed now. And then the cyano group, Cn minus, is going to come in, backside attack this position. Make a bond. When you make a bond, you break a bond. And then through hydrolysis, cyano will get hydrolyzed to carboxylic acid. And this will leave us with now our amino acid here, acid catalyzed hydrolysis, which is going to be, this is now the amino acid. This is actually, let's count carbon. So we have, I think we lost carbon 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, we lost this carbon here. So let me actually draw that carbon. So this is why it's very important to count your carbons, because I know this is supposed to be an amino acid, but as it currently stands, this is not an amino acid. So I knew that I lost the carbon in the process of drawing this, and this is a very good example to illustrate why it's so important to count your carbons. So we have a carbon here, and then that's where the cyano is going to come off of, and then this amino group. So now we have, this is isoleucine being formed here in problem C. Now in D, it's just like in B, so we deprotonate this alpha carbon, attack it onto this group, which we have 1, 2, and then we have this ester, which is going to be hydrolyzed into a carboxylic acid to give us now the amino acid. So we know it's going to be NCC. And then we know in step 2, that is going to be the R group that we're going to add on. So in step 2, if I have now 1, 2 carbons, so 1, 2 carbons, and then we're going to have carboxylic acid here. So we have 1, 2 carboxylic acid. So right off the bat, we can see that this is going to be aspartic acid being formed in D.